Hi everyone. Today we are going to see vector calculus and complex variable. In this we are going to see unit 1 as differentiation of vectors. So in this unit we are going to see vector point function, directional derivative, gradient, divergence, curl, solenoidal, irrotational, vector field and scalar potential. So first we are entering into the topic vector point function. So vector point function which assigns the value f is equal to f1i vector plus f2j vector plus f3k vector. Next we are going to see the gradient. Gradient is nothing but it is denoted as del. Del is a vector differential operator and the formula for the del is I vector tau by tau x plus j vector tau by tau y plus k vector tau by tau z. Suppose if it is denoted as del pi, then the formula will become I vector tau pi by tau x plus j vector tau pi by tau y plus k vector tau pi by tau z. Using this formula we are going to see the problems. Here is the problem based on gradient. So first one, prove that the gradient of a constant is 0. So I am taking pi of x comma y comma z be constant, then tau pi by tau x, tau pi by tau y and tau pi by tau z are 0. We know the formula for del pi. We have to prove that the del pi, the value is equal to 0. Which assigns the constant value. So tau pi by tau x, tau pi by tau y, tau pi by tau z, which all become 0. Hence the value of del pi is equal to 0. Here is our second problem. If pi 1 and pi 2 are scalar point functions, then we have to prove del of c1 pi 1 plus or minus c2 pi 2 is equal to c1 del pi 1 plus or minus c2 del pi 2, where c1 and c2 are constant. We have to take the right hand side and have to prove the left hand side. I am taking the right hand side as del of c1 pi 1 plus or minus c2 pi 2. So I know the formula for del, which is I vector tau by tau x plus j vector tau by tau y plus k vector tau by tau z into c1 pi 1 plus or minus c2 pi 2. Now multiply the c1 pi 1 plus or minus c2 pi 2 inside the bracket which includes I vector, j vector, k vector. Hence my equation will become I vector. So first I am differentiating. Take constant outside, c1 tau pi 1 by tau x plus or minus c2 tau pi 2 by tau x. Similarly for y and z. Now I have to take the value of c1 outside in all the three terms. So c1 of I vector tau pi 1 by tau x plus j vector tau pi 1 by tau y plus k vector tau pi 1 by tau z. Similarly plus or minus I am taking c2 as common. Hence the bracket will contain in pi 2. We know the formula for the bracket which will be del pi 1 and del pi 2. Hence my right hand side will become c1 del pi 1 plus or minus c2 del pi 2. So these are the problems based on gradient. Next topic we are going to see directional derivative. So formula for directional derivative is del pi into a vector divided by modulus a vector. In this we have to find the value for del pi and a vector, which is nothing but the direction. So it will be given in the question, a vector. For that we have to take the modulus. So modulus a vector. These three things we have to find and substitute in the formula. Hence we can find the value for directional derivative. Here is the first question. Find the directional derivative of pi value is given x square yz plus 4x z square at the point also given 1 comma minus 2 comma minus 1 in the direction of 2i vector minus j vector minus 2k vector. So using this pi we have to find the value for del pi. So direction is nothing but a vector. So a vector is given. So for that we have to take the modulus value. So we will see in the solution. So first we are taking the given value pi. We know the formula for del pi, which is I vector tau pi by tau x plus j vector tau pi by tau y plus k vector tau pi by tau z. So for the value of pi I am substituting inside for I vector, j vector and k vector. So first term differentiate the thing with respect to x. So x square will become 2x yz plus the second one x will become 1. So 4z square. second term, we have to differentiate the thing with respect to y. So x square, y will become 1 z. In the second one there is no y, so it will become 0. So my second term will become x cube z. Similarly for k vector, we have to differentiate with respect to z. So z will become 1, so x square y, then z square will become 2z. Already 4 in front of x, so 4 2s are 8, 8x z. In this, thus we found the value for del pi. There is a point given in the question. So del pi of 1 comma minus 2 comma minus 1, that is we have to substitute the value for x, y, z in the above del pi. So here I substitute all the thing and evaluate. We can find the value 8i vector minus j vector minus 10k vector. Thus we find the value for del pi. Next, a vector is given in the question. Write it out. Then take modulus for a vector. So we know the formula for modulus r vector is root x square plus y square plus z square. Similar formula is substituting here, which is equal to 2 square plus minus 1 the whole square plus minus 2 the whole square. So thus we can evaluate it and can find the value root 9, which can be written as 3. Thus the directional derivative formula is del pi into a vector divided by modulus a vector. Substitute all the terms. So we can find 8i vector minus j vector minus 10k vector into 2i vector minus j vector minus 2k vector divided by 3. So comparing I, j, k, that is we are multiplying, we get 8 2s are 16, minus 1 into minus 1 is plus 1, minus 10 into minus 2 is plus 20. Add all the things, we get 37 and the denominator is 3. Thus I find the value for directional derivative as 37 by 3. Similarly, we can find all the values using directional derivative. Our next topic is unit tangent vector. So the formula for unit tangent vector is dr vector by dt divided by modulus dr vector by dt. In the question, they will be given r vector. For that we have to take dr vector by dt, and similarly we can take modulus for that dr vector by dt. Let's see it in our problem. Our first problem, find a unit tangent vector to the following surfaces at a specified point. So the value of x, y and z are given, and also at the point t is equal to 2 also given. In the solution, we know the value for r vector, which is xi vector plus yj vector plus zk vector. So r vector can be written as, we can substitute the value for x, y, z in the question. That is, x value is t square plus 1, y value is 4t minus 3, z value is 2t square minus 6t. Now we have to find the value for dr vector by dt, that is differentiate r vector with respect to t. So the first term will become 2t and the second term will become 4. Third term will become 4t minus 6 into I vector, j vector, k vector, and also at the point given, now substitute it for t is equal to 2. So first term will become 4i vector plus 4j vector plus 2k vector. We find the numerator value. Now we have to find the denominator value, that is modulus dr vector by dt, that is root of 4 square plus 4 square plus 2 square. Expand it, we can get the value root 36. It can be written as 6. Thus the unit tangent vector is equal to dr vector by dt divided by modulus dr vector by dt. So substitute the values in the numerator and also in the denominator. In the numerator we can take 2 as common, so it will become 2 into 2i vector plus 2j vector plus k vector divided by 6. Cancel 2 and 6, we get 2i vector plus 2j vector plus k vector divided by 3. That's how we can find the value for unit tangent vector. Unit tangent vector formula is dr vector by dt divided by modulus dr vector by dt. We are moving to the next topic, that is normal derivative. The formula for the normal derivative is modulus del pi. Similarly, in the question they will be given pi value. For that we have to find del pi. Then we have to find modulus del pi. That's it for normal derivative. Here is our problem. Find the normal derivative of pi is equal to xy plus yz plus zx at the point minus 1 comma 1 comma 1. So write the given value as it in the question. So del pi, usually we can write I vector 2 pi by 2x plus j vector 2 pi by 2y plus k vector 2 pi by 2z. In short, I can write summation I vector 2 pi by 2x. That is summation I vector 2 by 2x. The value of x I am substituting here as xy plus yz plus zx. Now I have to differentiate these term with respect to x. So it will become y plus z. Now I expanding this. So y plus z I vector, z plus x j vector plus x plus y k vector. Thus I find the value for del pi, and also the point value is given. So I am substituting it for x, y, z. So my term will become 2i vector plus 0j vector plus 0k vector. I have to take the modulus for the term. I get root of 2 square plus 0 plus 0. So it will become root 4 is equal to 2. This is how I can find the value for normal derivative. That is normal derivative formula, which is equal to modulus del pi. Our next topic is unit normal vector. That is n vector is equal to del pi divided by modulus del pi. Similarly, we have to find the value for del pi, and also we have to take the modulus for that and substitute in the numerator and denominator. Then we can find the value for unit normal vector. Our first question is, find a unit normal to the surface xy is equal to z square. So this is the value for pi. At the point also given 1 comma 1 comma minus 1. So given pi value is xy minus z square. So bring this plus z square to the next side. We get minus z square. We have to find the value for del pi. I know the formula, so write it first, and the value of pi. So I am substituting it in the question. 2 pi by 2x xy minus z square. Similarly for j vector and k vector. In the first term, we have to differentiate with respect to x, so it will become y. Second term, differentiate with respect to y, so it will become x. In the third term, I have to differentiate with respect to z. I get minus 2z. So that is yi vector plus xj vector minus 2z k vector. Now I have to substitute the value of 1 comma 1 comma minus 1 to x value, y value, z value. So my answer is I vector plus j vector plus 2k vector. I have to take the modulus for that. So root of 1 plus 1 plus 4, that is root 6. Now I have to substitute these two things in the numerator and the denominator, so that my final answer is I vector plus j vector plus 2k vector divided by modulus 6. That's how we can find the value for unit normal vector. So normal is nothing but del pi, unit normal vector del pi divided by modulus del pi. So we are moving to the next topic, angle between the surfaces. That is theta is equal to cos inverse of del pi 1 into del pi 2 divided by modulus del pi 1 into modulus del pi 2. Here in the question we will get two value of pi. So we take one as pi 1 and another as pi 2. Have to find the value for del pi 1 and del pi 2. Then we have to take the modulus for both del pi 1 and del pi 2. So our first question is, find the angle between the surfaces. Z is equal to x square plus y square minus 3. So take this as pi 1 value, and x square plus y square plus z square is equal to 9. So take this as pi 2 value at the point 2 comma minus 1 comma minus 2. So substitute both for pi 1 and pi 2 for this point. So take the given pi 1 value and bring this minus 3. Sorry, x square plus y square minus z minus 3. So for that we have to find the value for del pi 1. That is, first we have to differentiate with respect to x. So it will become 2x I vector. Differentiate with respect to y. That is 2y j vector. Third term you have to differentiate with respect to z. That is minus 1. 1 into k vector is k vector. So for that we have to substitute the point value. 2 comma minus 1 comma minus 2. We get 4i vector minus 2j vector minus k vector. For that we have to take the modulus. Del pi 1 is equal to square root of 4 square is 16 minus 2 square is plus 4 minus 1 square is plus 1. So add all the things, we get root 21. Thus, we find the value for del pi 1 and also modulus del pi 1. Similarly, we have to find the value for pi 2 and del pi 2. Then modulus del pi 2. So, substitute in the formula. So, theta equal to cos inverse of first one del pi 1 value, second term del pi 2 value, and divided by modulus del pi 1 value is root 21 and modulus del pi 2 value is root 36 or else 6. So, I can multiply I vector, j vector, k vector. So, it will become 16 plus 4 plus 4 plus 4 into minus 4. So, minus 4 and plus 4 will become cancelled. So, 16 divided by 6 root 21. So, 16 and 6 will cancel each other. So, it will become 8 by 3 root 21. That's how we can find the value for angle between the surfaces. That is, theta is equal to cos inverse of del pi 1 into del pi 2 divided by modulus del pi 1 into modulus del pi 2. Next, the important topic, divergence and curl, that is irrotational and solenoidal vector field. So, divergence can be written as del dot pi del dot f is equal to 0. Suppose if it is curl, that is del cross f is equal to 0. So, divergence, it is say it in the next form as irrotational, and curl can be say it as solenoidal. Here is a formula given for divergence and curl. Divergence f vector is equal to divergence dot f vector, that is tau f1 by tau x plus tau f2 by tau x plus tau f3 by tau x. Del dot f vector is a scalar quantity. So, del dot f vector, it can be, next is curl. Curl f vector is equal to del cross f vector. We know the value for del. So, cross f vector, which can be written, see the fifth point. So, the formula for the curl, that is del cross f vector is equal to I modulus I vector, j vector, k vector, tau by tau x, tau by tau y, tau by tau z, f1, f2, f3. So, we will see it in the problem. So, here we are going to see divergence and curl. So, divergence is del dot f vector is equal to 0. Curl is del cross f vector is equal to 0. Here is the first problem given. If f vector is equal to x square I vector plus y square j vector plus z square k vector. In this, x square, y square and z square denoting f1, f2, f3. We have to find the divergence and curl, that is del dot f vector which is equal to 0 and del cross f vector which is equal to 0. So, first of all, write the given value of f vector. First one, we have to find the divergence, that is del dot f vector. We know the value for del and also the f vector which is given in the question. So, multiply both the thing, we get tau by tau x into x square plus tau by tau y into y square plus tau by tau z into z square. Now, first term differentiate with respect to x, that is 2x. Then differentiate with respect to y, 2y. Differentiate with respect to z, 2z. So, hence I find the value for the divergence, that is del dot f vector is equal to 2x plus 2y plus 2z. Next, we have to find the value for curl f vector, that is del cross f vector. We know the formula, modulus I vector, j vector, k vector, tau by tau x, tau by tau y, tau by tau z, and the value and for the value of f1, f2, f3, I can substitute it as x square, y square, z square. Now, I have to elongate it, so I can get the value, all will become 0. So, that is del cross f vector is equal to 0. 0 I vector, 0 j vector, 0 k vector. So, the answer is 0. That's how we can find the value for divergence and curl. Here is another point given, solenoidal vector and irrotational vector, which is nothing but the divergence which is equal to 0. If I can show the divergence is equal to 0, then it can be say it as solenoidal. If the curl del cross f vector is equal to 0 means it is a irrotational vector. Here is the first